Assalamualaikum. Today we will present our project on algorithm data structure, focusing on solving the marketing campaign optimization problem or MCOP. MCOP is similar to the traveling salesman problem, where a marketing team must visit several locations exactly once and return to the starting point while minimizing total cost. In our case, the location include UPTM, CTB, CTC, and CTD. The goal is to find the most efficient route using different algorithm technique. First, I will explain the greedy algorithm. A greedy algorithm works by always choosing the best option at the current step without considering future consequences. For MCOP, start at UPTM, choose the nearest city, and repeat until all cities are visited. Based on our cost metric, the route is UPTM to CTB to CTD to CTC, and the last one is UPTM. The advantage of Greedy is that it is fast and simple. However, it does not always guarantee the optimal solution because it only focuses on short-term decision.
Assalamualaikum. My name is Ishaq bin Ismail, and today I would like to present to you about divide and conquer. Divide and conquer is an algorithm paradigm that recursively breaks a large problem into smaller independent subproblems of the same type. Solve each subproblem directly and then combine their solution to form the solution to the original problem. There are three step structure of divide and conquer. The first is divide. Divide is where split the problem into smaller sub-problem that are independent for each other. Each other. The second one, conquer. Conquer is solve each sub-problem recursively, and if a sub-problem is small enough, then we need to solve it directly. The last one is combine. Combine is where we merge the sub-problem solution to construct the final answer. In MCOP context, the routing network is partitioned into separate regions or segments, and each segment optimal path is computed independently. The segment paths are stitched together to form a complete route, and there are limitations of divide and conquer where MCOP constraints interact across segments. The combined route may not be globally optimal. For instance, merge sort, quick sort, and binary search. Okay, next we go to dynamic programming. Dynamic programming is an algorithm technique for solving optimization problems by breaking them into smaller overlapping sub-problems. Solving each sub-problem only once and storing the solution in a table to avoid redundant computation, thereby guaranteeing a globally optimal solution when the problem exhibits optimal substructure and overlapping sub-problems. There are two key properties required, and the first one are optimal substructure. An optimal solution to the problem contains optimal solutions to each sub-problem. The second one are overlapping sub-problem. Overlapping sub-problem are the same sub-problem are solved multiple times in a naive recursive approach. There are two implement, implementation style of dynamic programming. The first one are top-down, or known as memoization. Top-down or known as memoization is where is recursively solve sub-problem and cache result. The second one are bottom-up, or known as tabulation. Bottom-up is where interactively fill a table from smallest sub-problem outward. Okay. Then, in MCOP context, each node state store the best cost, the best cost to reach under multiple constraints. For instance, cost, time, and risk. Then, computed path costs are used when the same subpaths appear in different routes. This ensures the true optimal multi-constraint path is found, not just a locally good one. For example, Fibonacci sequence, knapsack problem, shortest and shortest path. That's all from me.
So next for algorithm, which is backtracking. Backtracking is a recursive depth first algorithmic technique that builds candidate solutions incrementally and abandons a candidate as soon as it determines the candidate cannot lead to a valid solution. It systematically explores a state space tree, running entire branches when constraints are violated, which makes it significantly more efficient than brute force enumeration. In the context of the Malaysian Certificate of Proficiency (MCOP) or STPM Computer Science syllabus, backtracking is a tough under problem solving and programming as an advanced strategy for constraint satisfaction problems. Key concepts tested include the implementation of the choose to the explore to the unchoose recursive pattern, the ability to identify dead ends early through pruning, and the visualization of decision path as state space trees. Classic exam problems that illustrate this include the queens problem, placing queens on the chessboard so none attack each other, maze solving, finding a path from start to exit, and Sudoku or graph coloring puzzles, all of which require students to demonstrate how recursion can efficiently navigate complex decision trees. So for the next algorithm is sorting and searching. Sorting and searching are two foundational classes of algorithms used for data organization and retrieval, forming the core of data structures and algorithms in the Malaysian curriculum. Sorting algorithms rearrange elements of a list into a specific order, usually ascending or descending, ranging from basic methods like bubble insertion and selection sort to advanced divide and conquer techniques like merge sort and quick sort. Searching algorithms locate a specific target value, with a student expected to master linear search, which works on unsorted data, and binary search, which is far more efficient but strictly requires sorted data. A critical exam concept in the MCOP context is the independency between these two, which is binary search is only valid after sorting, so students are often asked to compare the total computational cost of performing a sort plus binary search combination versus repeated linear searches, testing their ability to analyze time complexity and select the optimal strategy for a given problem constraint.
Assalamualaikum. My name is Muhammad Anas and I will talk about comparison of algorithm. Think of algorithm as different tools for different jobs. First, algorithms. Greedy algorithms are the fastest. They just grab the best option right now, but they often miss the best final answer. What about divide and conquer? Divide and conquer is great for splitting bigger problems into smaller ones, but it fails when those smaller problems overlap. Now, dynamic programming. Dynamic programming is like a smart planner. It remembers past answer to guarantee the best result, though it uses more memory. What about backtracking? Backtracking is the most true. It tries every single path to find the perfect solution, but that makes it very slow. Lastly, sorting and searching. Sorting and searching are just the basic. We need to organize and find data quickly. So, which one wins? Greedy is fast but risky. Backtracking is accurate but too slow. That leaves dynamic programming as the clear winner for the MCOP. Why dynamic programming, you ask me? It's the simple reason. MCOP problems are like a lot. The famous traveling salesman problem, where a salesman must find the shortest route to visit many cities. These problems always have two special features. The first one is overlapping subproblems, and the second one is optimal substructure. Overlapping subproblems, you can say like you keep solving the small puzzle over and over again. And optimal substructure is if you solve the small puzzle perfectly, this problem you can combine them to solve a bigger puzzle perfectly. Dynamic programming is the best choice because it solves each small puzzle just once and saves the answer. This avoids the slowness of backtracking and mistake of greedy, giving you the optimal score every time. For MCOP, where accuracy matters the most, dynamic programming is the ultimate strategy. That's all from me for this presentation. Thank you so much for listening, and I hope this helped you understand why dynamic programming is so powerful for MCOP problems.